Hi guys, welcome to the analog lecture series. So in the last class we saw for this question how to do AC analysis and why we are doing AC analysis, right? See, first of all, in the last class we did DC analysis to calculate the value of RE. I haven't started AC analysis yet, but I told you why we are doing DC analysis when we are solving the question in AC analysis. Actually, the question is we have to calculate the voltage gain. For that, we have to do AC analysis. But in AC circuit, we need to know the value of some parameter. That parameter can be calculated only in DC analysis that we did already. Now it's time to explore the circuit in AC analysis. So in AC analysis, first of all, let me tell you some standard things that you have to follow always we are doing AC while doing AC analysis. The step number 1 is deactivate all DC sources. Deactivate all DC sources. It means what we need to do, the first thing is, if given it is a voltage source, you have to deactivate it by short circuit, just to short circuit the voltage source. Suppose no sir, given it is the current source, so in case of current source, just open circuit. That is the first step. And the next thing is we are doing low frequency analysis, right? So in low frequency analysis, while doing AC analysis, always short circuit the all capacitors. Short circuit all capacitors. Short circuit all capacitors. So in our question they haven't shown any capacitors. It means they have short circuited the capacitor by themselves. In the question itself they have short circuited. In the upcoming lecture I will be bringing more extraordinary questions. There we will be having so many capacitors. I will teach you how to short circuit. At last, at the end of the lecture, I will tell you basically where we are going to short circuit the capacitor. Internally there are few more capacitors, how to construct all those things. Slowly we will be cracking such that you will get the complete idea about the AC analysis. Okay, so as of now, short circuit all the capacitors, whatever that will be given to you. Okay, that is the second step. So after short circuiting the circuit capacitor, we have to redraw the circuit or redraw the AC circuit. Redraw AC circuit. Now while redrawing the AC circuit, it is very important to know the equivalent circuit of the transistor. In AC, sir, in DC directly what we are doing is, let me tell you, when we are doing DC analysis, if we are having a transistor, it may be NPN or PNP, I am taking NPN. If you are having a transistor while doing DC analysis, when we are traveling from base to emitter, what we are doing? Directly we are replacing the transistor by equivalent battery voltage. Similarly, when we are going from collector to emitter also, we are replacing it by collector to emitter voltage. That is what we are simply doing when we are doing DC analysis. That's all. That is the equivalent circuit, and we can proceed further with this. But when we are doing AC analysis, what is the equivalent circuit of the transistor, sir? It is common for both NPN and PNP. So don't think, sir, for PNP what will happen? Nothing will happen. You can take the same circuit, right? So let me draw the equivalent circuit of the transistor when we are doing AC analysis and we are doing low frequency analysis. Don't forget that. So in low frequency analysis, you can replace this transistor by, so first model, you can go up with the RE model. You can go up with the RE model. It means this entire transistor will be replaced. I am starting from base terminal, then I will be showing you one by one. So what we have to do is, this is collector terminal, this is base terminal, this is emitter terminal. So this will be completely replaced by, sir, derivations are there, but I told you we are directly taking question and we are learning exactly what is required in order to crack the question. So I am not giving any proof for these things, but I am just giving you how to do this directly. This is the final conclusion or final equivalent circuit. We have to see, this is the equivalent circuit of the transistor. Here this is defined as beta times of RE. In case of RE model, this is how we are drawing the equivalent circuit for the transistor. I told you there will be another model. The another one is, no sir, I don't want to go with this procedure. I would like to go with the pi model. So you can also redraw the circuit in terms of pi model. So always while doing the AC analysis, simply replace the transistor by pi model also. Pi model means same, you have to draw one resistor here, and then this side you have to draw one current source. Yes sir. So here the value of current source is GM. into V pi, and here V pi is nothing but voltage drop across the R pi. So later while solving the problem you will be getting the complete idea, don't worry about it. Sir, here which one is collector terminal, which one is base, which one is emitter? So here this is going to be your base terminal, of course this is your collector, and this one is going to be your emitter terminal. Similarly here also you can consider this one is going to be your base terminal, this is going to be your collector terminal, and this one is going to be our emitter terminal. So this is how we are drawing the equivalent circuit for the transistor. There will be one more model, that is called hybrid model. So the last one is R, we can also write hybrid model, that is called H model. You can also replace the transistor by H model. In that case again draw the same circuit as usual, only the parameters will be different. That is, we are doing different approaches in order to reanalyze the circuit. Anyway, the famous model is RE model. That will give you the very simple answer. Initially people were always solving the transistors by using hybrid model only, H model, but nowadays it became very smart. Smart in the sense, RE model is simplified the circuit as simple as possible. We can easily solve the questions just by using RE model. So that is the standard or famous one. So as usual, this is going to be base, this is going to be collector, and this is going to be emitter terminal. Okay sir, now it's time to solve the question. Let us go ahead with the RE model. I said this is the famous model, right? So you can go up with this model. Take our transistor. Let me show you how to do this. So we have to take the transistor, short circuit all DC sources. See that this is DC, this is DC, it will be short circuited, and we know, see there, this entire circuit, it will be acting as a diode, I told you, and diode equivalent circuit also I have drawn, RE plus we have to consider cut-in voltage, but while doing DC analysis, while doing AC analysis, this voltage will be short circuited. So this entire branch will be replaced by a single resistor. Of course that resistor value is RE, we have also calculated that value is 10 ohm. So replace it by single equivalent resistance and RE, and that value is 10 ohm. Okay sir. Now you also know how to replace this transistor. So now it's time to explore the circuit. Start from AC source. So let me draw it. It's very it is very easy and it's quite interesting to learn. Let us start from AC supply. Yes sir. After that we are having a transistor. I told you replace the transistor by its equivalent resistor. See there how I am doing. Transistor will be replaced by RE. This is beta times of RE, and this side we are having current source. Yes sir. This is just replace the transistor by its equivalent circuit. After that you can connect all other parameters, available parameter. See, this is going to be your base terminal, this is going to be emitter terminal, this is collector terminal. Now observe, in the collector terminal what we are having? Sir, in the collector terminal, this is collector terminal, we are having 1.2 kilo ohm resistor that will be connected with the ground. DC voltage will get short circuited, right? So see there, this is collector terminal. Here we are having 1.2 kilo ohm resistor that will be connected with the ground. So you can just draw this 1.2 kilo ohm resistor. After that, if you observe the emitter terminal, just observe, emitter terminal is having 1 kilo ohm resistor. Of course, with that in parallel, we are also having one more resistor, that is called RE. Yes or no? I told you. Now this is the emitter terminal. Here we are having 1 kilo ohm resistor. With a parallel, we are having that equivalent circuit of the another transistor, that is RE, and this is going to be 1 kilo ohm resistor, and this both are will get connected with the ground. That's all. Fine sir. Now sir, where we are going to observe the output? If you observe the circuit, see there, I forgot to mention that this is the output port. Here they are going to measure the output voltage. Of course this is the input port. They told na, in the circuit if you observe, see there, this is the port where we are going to observe the output voltage. Okay, I haven't mentioned that, but that port is already given. It means, where is that? This is the collector terminal. If you extend this, this is the point where we are going to measure the value of output voltage. Some of you might be having confusion here. Sir, how that V0 came across 1.2 kilo ohm? See there, this DC voltage will going to be short circuited. Whereas this is the point where we are going to measure the voltage. It means this is positive terminal. Obviously, while measuring the voltage, there will be one more terminal. That terminal will be connected with the ground only. Now this 1.2 kilo ohm resistor also having two terminal. One terminal is connected across the V0, another terminal is connected with the ground. V naught also having two terminal, one terminal is connected here, another terminal is ground. So both are same or not? This 1.2 kilo ohm are also having same terminal like ground and V naught. V naught also having same terminals, one terminal is here, another one terminal is ground. It means both are being placed at the same position only. Now I hope you all understood till this point. What is the question, sir? The question is voltage gain of the circuit is what? If you understand, I have been already delivered 2 lectures. Now if you understand this pattern clearly, nothing you need to do. Just apply the common sense, whatever the things that we observed. See, this is collector terminal. Actually for externally collector current will go here. This is base terminal, base current will go here, NPN transistor. This is emitter terminal, emitter current will go here according to DC analysis. Just to take all those things, you don't need to do anything. Replace the transistor by its equivalent AC, that's all. After that you can consider all other parameter as it is. Collector current means this is the collector terminal, then collector current only will go here. But you all know collector current can also be written IC is equal to beta times of IB. So that relation, that's why in across the collector through the collector terminal we are putting beta into IB. I told beginning of this there is a big derivation. We are not going to that. We are learning directly from the questions. Okay, fine, sir. Till then we understood how to draw the equivalent circuit. Once you understand this question, then automatically in the upcoming questions you can do everything by your own, because this AC analysis is very easy. Only one question you have to understand properly. If you properly understand how to calculate voltage gain, then you can easily calculate the current gain. You can also easily calculate the output impedance, input impedance. Okay, so this is all for this lecture. Here I am just requesting you, try to bring the relation between output voltage and input voltage. Apply KVL, KCL, whatever the things that you want, but I just wanted to know the relation between this output voltage and this input voltage. Apply your smart mind. So in the next class I will be giving the answer for this question. I know we are going 4 part because this is very important. Once you understand the first question, then the upcoming questions will be very easy. Okay, the rest of things we will see in the next class. Spend some time, use your mastermind to get the answer for this question. Okay, this is all for this lecture. Remaining things we will see in the next class. Thank you all.